Alright, so now let's make the second type of prediction, the prediction of a single data point, meaning patient, with the following features. So, my apologies to any doctor that could be here in this course if those feature values don't make any sense. I don't have much expertise, so that's why I just went from 1 to 9 just to make it easier to input. But of course, we're only doing this to practice making the prediction of a single data point. So let's add a new code cell. Now, basically, we have to do exactly the same as what we did here with these predictions on the test set. So what we could do is, copy this, and let's see the only thing that we have to change for our single prediction. All right, so pasting that here. Okay, so we take our model. From our model, we call the predict method. And then, of course, we'll have to apply the transform method again from our scalar SC object. But then this needs to be replaced by what? Remember, it needs to be replaced by an array of 2 dimensions which will contain the values of our patient here. And so we enter a double pair of square brackets, and then, of course, we don't forget to exclude this first number. I just wanted to give you this little trap to make sure you keep good track of the right features to input in the predict method. And so there you go. We just have to enter those feature values in the same order. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right? And so that's exactly how you need to enter the feature values of a single data point, here patient. And so here we go. Let's make our prediction, and let's see if this patient has a benign or malignant breast tumor. Let's play and run. And our model predicted 4. So sadly, our model would predict a malignant tumor for this patient. Okay, congratulations again if you were able to do this. You now know how to make a single prediction even if feature scaling was applied in data preprocessing. Alright, congratulations. Now we're going to move on to part 3, evaluating the model. And we will do that in 2 steps. First, we'll compute the confusion matrix, which will give us the true positives, true negatives, and false positives. And then we will compute the accuracy, which should be really good based on our first observations of the predictions in a test set. I can't wait to show you what it's going to be. And until then, enjoy machine learning.